In this video, we're going to be looking at how we can find the nth term rule for a quadratic sequence. Looking at the sequence I've been given and the differences between any two consecutive terms, I can see that it's going up by 5, then it's going up by 7, then it's going up by 9. So it doesn't have a first line of common differences. If I look at the second line of differences, this time it is common. So if I wanted to continue a sequence, I could add 2, which would mean that the difference between the fourth and the fifth term would then be 11, and that would then make it 40. But I want to not just find the fifth term, I want to be able to find the 100th term or 200th term without having to keep continuing the sequence on. Now the fact that this sequence has got a second line of common differences would imply that it's got n squared, or at least an squared, within the rule. The nth term for a quadratic sequence would be an squared plus bn plus c. And my task is to find the value of a, b, and c in order to answer this question. To find the value of a, it's half the second line of difference. So a half of 2 is equal to 1, and this is the value of a. So my rule is n squared plus bn plus c. Now my sequence is 8, 13, 20, 29, and I now know that it's based on n squared plus bn plus c. The sequence n squared is 1, 4, 9, 16. Now looking at my two rules, you'll notice that if I was to take away these two rules, n squared take away n squared would give me nothing. But it would leave me bn plus c. If I was to then look at this sequence and say 8 minus 1, well that's 7, 13 minus 4 is 9, 20 minus 9 is 11, and 29 minus 16 is 13. We can now see that I've got a linear sequence, which is represented by bn plus c. It's got a common difference of 2, so I know that it's based on the 2 times table, 2n. I also can see that it's a shift of plus 5. The 2 times table shifted by plus 5 would then give me 7, 9, 11, 13. So returning back to my original quadratic, if I know that the value of a is 1, it's based on n squared. I've now found the value of b and also the value of c. So the rule for my quadratic sequence is n squared plus 2n add 5. Pause the video here and have a go at the question on the right hand side. When you're ready for the answer, press play. So looking at this sequence, it goes up by 5, by 7, and by 9. It has a second line of common differences, which is plus 2, which means that this rule is based on n squared plus bn plus c. The sequence was 5, 10, 17, and 26, and because it is based on n squared, the n squared sequence is 1, 4, 9, 16, the first 4 square numbers. Taking these away gives me 4, 6, 8, and 10. And looking at the rules, this would leave me bn plus c. This sequence is going up by 2. So it's based on 2n, and it's the 2 times table shifted by plus 2. That means that my sequence is n squared plus 2n plus 2.